All right, so kind of like as we've been kind of talking about with this code, we have these IE and IH parameters and this density matrix. That's kind of the whole deal of what we're trying to figure out. And then, as Adam was talking about, we have our input files here. So I won't go over that. For my model, I am running bands 347 and 376. And just one other thing to watch out for in the for loop for the band integrate. You do want to watch out for changing these numbers and make sure that you notice that it's a less than sign, not a less than equal for the upper band, because that might screw you up. So the way that density matrices are represented, as we were talking about, so we start by offering these parameters IH and IE, which actually I'll skip ahead a little bit. Basically, what they are counting is the band number you are away from the HOMO or LUMO. So for the initial hole, it's counting the number of bands below LUMO you are, and for the initial electron, it's the number of bands above HOMO. And so that's just kind of highlighted here. So then back here, what we have is this initial, an example of an initial density matrix for the electrons, where the time step may be the columns, and then each different orbital or band is the rows. So we're starting out with a electron all the way excited in band 4, I guess, above HOMO. Over time, this will get evolved, I guess, and fill in all of these extra zeros that you see past time t equals 0. And that's just using this code snippet on the bottom, I believe. For the size 0, that is used to calculate some of the coefficients that Landon was talking about before. And that's just the first column of this PPE matrix. And then I guess for the holes, it's basically the same story, just kind of reversed, because then you're counting down from LUMO. Once you decide to put whatever IH and IE you have, we have this similar sort of graph that Adam was looking at again, which is just showing the energy of the holes and electrons over time, along with like their relative densities based on the color. So as we can see here, we have the hole exciting, I guess, and the electron relaxing, as we would expect. And that is all I have.
Okay, please join me in thanking Phil. So, any questions in the face-to-face room?
This is just more a question about the code itself. Whether you have it set up for the excited states, give you one less orbital, since it has to count when you go at all.
Yeah, I guess because you would have to like count over that, so it won't necessarily be.
It'd be 8 down and 7 up. Or 7 up from the LUMO.
Yeah, I guess like in this code, it will be 8 up from the HOMO, and then it will be 7 down.
So notice like how he has it described, where he has the IH related to HOMO and the IE related to.
Yeah, but the IE is counting from above HOMO, so it would be counting LUMO and then 7 more up.
Yes.
Yes.
That's correct.
IH would be counting 8 down from HOMO.
No, you notice he has IH related to LUMO, not HOMO.
Yeah, so you start at LUMO, not HOMO. So then they have like a little bit like overlap in the HOMO area, I guess.
Great question. Thank you, Stephen. Joseph, can you please go one back? Yeah. Yes, here. So initial condition that we were discussing with one, say no. So here it shows IE equals 3, I think, for LUMO plus 2, right? So if you want technically to try IE, if you want to start from home, you have a trivial dynamics with no dynamics. Matrix indices by convention do not accept index equals 0. So it should be natural, like amount of apples. It cannot be 0, right? Therefore, we make this offset by 1. Still, does it make sense? We do have a question from Lola in the chat line.
How do you decide what to select as your IE and IH? So, it's a great question. So you'll start probably by looking at the oscillator strengths between like kind of all combination bands that we would get from when we calculate the absorption spectra. And then you basically would want to start looking at like the highest oscillator strength transitions. And that will be like the most likely states or transitions that you would expect to happen. For this example, I didn't necessarily follow that rule. Kind of like Adam was mentioning, there was a little bit of a problem with the code that I wasn't able to figure out. So if I made my hole too low, then I would get a kind of odd sort of energy draft. So this one is just kind of almost like a random set of IE and IH that produced a nice looking picture.
Oh, are you satisfied with the answer? Okay. Yeah.
Awesome.
Okay, more questions to Joseph? Questions 1, questions 2, questions 3. Let's thank him once again.